Hello, YouTube community. In this video, I'm going to get into nuclear fuel. Then we're going to start off with the brand new fuel. Then later we can get to talking about long-term dry cask storage. So let me get out of the way.
Generates electricity by using nuclear fuel, which is made into small pellets and placed into long tubes called fuel rods. The rods are placed together into a fuel assembly. The fission process takes place after a fuel assembly is placed into the reactor. This produces heat to create steam, which turns a turbine to generate electricity. Fuel inside the reactor must be replaced periodically, a process that is completed during Diablo Canyon's scheduled refueling outages. New fuel is benign when it arrives at Diablo Canyon because it is not yet activated by the fission process inside the reactor core. Before it is placed into the reactor, it needs to be inspected. Workers use gloves and handle it with care, maintaining a high level of cleanliness to protect the integrity of the fuel before it is transferred to one of Diablo Canyon's spent fuel pools for storage. The spent fuel pools store new fuel as well as the used fuel that has been removed from the reactor core. When new fuel is placed into the reactor, it generates power for 3 to 5 years. When its cycle is complete, it is moved to wet storage for cooling before it is transferred to dry storage.
So you see, we just talked about the new fuel. So the U.S., we enrich uranium, then we build it into a stack of pellets that are inside those metallic rods that are in a fuel assembly. And those can operate multiple cycles in a core. Then after that, it would be called used fuel. So this next section is going to jump into the used fuel portion.
Until 2009, all the fuel used to power Diablo Canyon was stored in the site's spent fuel pools, a storage method that is safe and used in the U.S. and around the world. The spent fuel pools are designed to be seismically safe. Built into bedrock, the walls are constructed with reinforced concrete that are approximately 6 feet thick and lined with stainless steel. Inside the 40-foot deep pools, used fuel is stored in a grid structure called a rack. Since the fuel assemblies are 14 feet tall, the top of every assembly is submerged under more than 20 feet of water, which keeps the used fuel cool until it is ready to be transferred to dry storage. This deep barrier of water provides shielding from the radiation emitted from the used fuel, which is not strong enough to generate electricity, but still emits heat and radiation.
You see there, we're talking about the actual fuel, and then it's stored in the racks in the spent fuel pool. And then eventually we'll take that fuel and we'll put it out into dry cask storage. So just some of my background, I've actually had experience with some of the design improvements and validations that we've made with the nuclear fuel. They talked about in the video about the 40 feet of water providing a shield. If you get around 10 feet of water, it gives you tremendous shielding. We had the technical ability to actually take those fuel assemblies apart. And I've been a part of taking them apart before to validate some designs that we've adopted to continuously improve the nuclear fuel. So let's jump into fuel transport now.
Diablo Canyon uses Holtec International's High Storm 100 SA system to transfer used fuel from the pools and place it into long-term dry storage. The entire process, from the pool to the pad, meets the Nuclear Regulatory Commission's site-specific criteria and was designed with seismic safety in mind. This method is trusted worldwide and was selected by PG&E following an in-depth regulatory oversight and public participation process. Transferring used fuel from the pools to dry storage begins with a 15-foot-tall stainless steel alloy storage canister. The canister is placed inside a separate multi-walled lead and steel transfer cask that is used to transport the internal canister to the used fuel storage pad after it is loaded. Together, they are placed into a designated location at the bottom of the spent fuel pool, where workers load used fuel assemblies into the storage canister's internal grid structure. After the canister is filled with up to 32 fuel assemblies, a heavy stainless steel lid is lowered into the pool and secured to the top of the canister, which is then lifted out of the pool by an overhead crane. After the lid is welded to the top of the canister shell and moisture is removed from inside, the cask is moved to Diablo Canyon's independent spent fuel storage installation, often referred to in the industry as an ISFSI. Workers use a vertical cask transporter specifically designed to safely transfer used fuel to the ISFSI, which is equipped with seismic restraints and bumpers. In 2005, Diablo Canyon began construction on its ISFSI. The completed installation is comprised of 7 individual pads that are built on solid bedrock and have a collective capacity to hold all the fuel used during the life of the plant in an area smaller than a football field. Each of the 7 ISFSI pads are approximately 8 feet thick, constructed with 2,000 cubic yards of concrete and 206 tons of reinforcing steel. The ISFSI was also designed to anchor each cask into the pad for strength and seismic safety. Each cask is fastened to a steel plate on the pad's surface with 16 bolts. Below the surface, 16 2.5-inch thick steel bars connect this top plate to a corresponding plate at the base of the 8-foot thick pad. Diablo Canyon began the process of transferring used fuel to the ISFSI in 2009. The ISFSI operates under a site-specific license that is issued by the Nuclear Regulatory Commission and is separate from Diablo Canyon's operating licenses. PG&E and the Nuclear Regulatory Commission routinely conduct inspections of the casks to ensure that they are fully compliant with stringent guidelines and that they fulfill their safety function as required by the materials license.
So you can see there that it's all licensed. This was developed over many years. What's impressive with the fuel is actually contained. How many industries do you believe can really account for their waste stream? The waste stream that's been generated in these nuclear power facilities is very tightly controlled. There's actual economic value to that used fuel. For example, there's a company right now, Oklo, OKLO, you could go look up, that's working on licensing a nuclear plant that's actually going to be operating off of using the used fuel. And that's already been tested and performed in Idaho and with the EBR-2, Experimental Breeder Reactor 2, that operated for like 30 years. So all the technology is proven. It can be done. It's just a matter of, investing the time and money. So looking forward, things are looking promising. So let's jump more into some more details with the nuclear fuel cycle.
Before the transfer cask arrives at the ISFSI, workers prepare what is called an overpack, which encases the inner canister for long-term storage. The overpack is prepared by filling its inner and outer cylindrical steel shells with concrete. As the inner canister is lowered into the overpack, seismic restraints are used. The cask is then bolted shut with a steel lid and bolted to the pad. A loaded Holtec cask is 11 feet in diameter, 20 feet high, and weighs about 360,000 pounds. It is engineered to withstand extreme natural hazards and seismic events. In addition to cask strength, the ISFSI pad is located 300 feet above sea level, protecting it from a severe wave event, as well as from rising sea levels that are a result of climate change. The Electric Power Research Institute, or EPRI, is an independent nonprofit organization that conducts research on the health, safety, and environmental effects on energy generation. EPRI conducted inspections of Diablo Canyon's Holtec canisters and issued a report in 2016 indicating that no signs of stress corrosion cracking were found. You can access EPRI's report by visiting EPRI.com, clicking on Research, then typing Diablo Canyon into the search field. The Nuclear Regulatory Commission requires that recurring inspections for stress corrosion cracking be conducted as part of ISFSI license renewal aging management. PG&E operates a second ISFSI in California at the decommissioned Humboldt Bay Power Plant. Seen here is an ISFSI inspection conducted at Humboldt Bay Power Plant to meet Nuclear Regulatory Commission requirements.
So, why don't you give me a comment on what you think? We've got proven technology for safely handling the fuel. As you saw when it came in new, you can handle it by hand, basically. Keep gloves on, though. We don't want anybody's little sticky fingers touching the fuel to cause a problem with the actual fuel. And actually, we've done a lot of inspections. We really control where the fuel is placed in the reactor core. And a lot of fuel is reused in the next operating cycle. Just want to make sure people have a better understanding of that. Approximately a third, it all depends on the plant design and the different characteristics, but you can assume about a third, which, different plant designs, it could be 70 to 80, maybe more assemblies, are actually taken to the spent fuel pool. Now, that's after operating maybe a year and a half. Some people are on a 2-year fuel cycle. So tremendous amount of energy when you think about it in such a small package. And I've got experience looking at the data with solar generation. I personally own solar. I can tell you on a cloudy day, I can just watch it drop. Also, battery storage. I'm very familiar with battery storage. You got to charge them. Batteries don't run 24/7. So you're seeing a lot in the news right now with data centers. What's going on is it's clear that if you need a large amount of power, Microsoft, Amazon, all the biggies are all leaning toward now. They're looking at nuclear facilities to power the data centers. The reason they're looking at that is because it's 24/7. It's highly reliable. The plants have done well with the horrible weather conditions that have existed. There's many nuclear. I was at one nuclear plant. I'll just do personal testimony. We shut down for a hurricane, which meant we just inserted the control rods and we were ready to step back on the grid as soon as it's all clear. After the storm cleared, you make sure the power lines are still functioning. You got to be in a safe state. You don't want electricity causing problems. We shut down for the storm. The storm, actually, 2 of them that I was experienced with being at the plant when they came over the plant. We were ready to come right back up and go online. The rest of the infrastructure in the state needed a lot of work. You'll see in the news, the different power companies and linemen coming in and helping. It's a big, huge effort. It's a lot of really smart, hardworking guys, and hats off to those linemen. We just went through that here in Florida with Hurricane Milton. Also, you guys saw what Helene had done throughout North Florida and into Georgia and North Carolina, and a lot of work has gone into the restoration effort. There's been a lot of hardworking people in the power industry, so we should all really give them a big thanks. There's a lot of hardworking guys out there. So let's jump